Have you ever wondered why, say, the Amazon is always hot and rainy, but the Sahara is just bone dry? Well, today we're going to take a super fast tour of the globe to make sense of the planet's different climates. And it all starts with one really simple but super important idea.
Okay, so check this out. Egypt has no weather, only climate. Now, I know that sounds kind of weird, right? But it actually perfectly nails the very first thing we have to get our heads around: the huge difference between weather and climate.
So here's the simple breakdown. Weather, that's the short-term stuff. It's the rainstorm that's hitting you today or the sunshine you're hoping for tomorrow. Climate, on the other hand, that's the big picture. It's the average of all that weather over like decades. It's the pattern. It's why you just know Egypt is going to be hot and dry. Honestly, the best way to remember it is this: weather is what you get, but climate is what you expect. All right, so here's the plan for our 5-minute world tour. First, we're diving into the planet's tropical engine room. Then, we're going to visit the world of extremes. After that, we'll see what it's like living in the middle. And to wrap it all up, we'll connect all the dots and see how this is all one big connected system. You ready? Let's go. Okay, first stop, the tropical engine room. We're heading right into the planet's steamy, rainy heartland. So you'll find this hot, wet climate wrapped in a pretty tight band right around the Earth's equator. Think of places like the Amazon Basin, the Congo Basin, and big parts of Southeast Asia. This is basically the planet's ground zero for heat and humidity. But what does it actually feel like to be there? Well, this data postcard from Kuala Lumpur pretty much says it all. Just look at that red line for temperature. It's almost completely flat, a super steamy 80 degrees Fahrenheit all year long. And those blue bars? That's the rain, a whopping 95 inches a year, with a serious downpour pretty much every single month. There's no winter, no summer, just one long, hot, wet season. And here's the secret to why it rains so darn much. It's a daily cycle, and it happens like clockwork. The intense equatorial sun just beats down, heating the ground and all the moist air above it. So this hot, wet air starts to rise. As it gets higher, it cools down and condenses into these enormous thunderclouds. And the result? A massive downpour, usually every single afternoon. This is the engine that drives the tropics. All right, let's do a complete 180. Next up, the world of extremes. We are jumping from the consistent, steamy tropics to the driest deserts and the most frozen poles on the planet. So here you can see the two faces of extreme. On the left, you've got the world's hot deserts, places like the Sahara, all clustered in those mid-latitudes. And on the right, you have the vast, frozen landscapes of the Arctic and Antarctic. I mean, they couldn't look more different, right? But what they share is that they are both defined by their absolutely extreme conditions. And, the climate graphs really tell the whole story. For the hot desert, look at that. The rainfall bars are practically non-existent. It's all heat, zero water. Now, let's jump over to the Arctic. The temperature line, wow, it barely creeps above freezing for the entire year. So you've got one place defined by a total lack of water and the other by a total lack of heat. But here's where it gets really interesting. What if I told you that the intense dryness of the desert and the bitter cold of the poles are actually connected? It sounds crazy, but they are. Stick with me for a minute. We're going to put this whole puzzle together very soon.
But first, let's make a stop in the places where, well, a whole lot of us actually live. Welcome to the middle ground. We're exploring the temperate zones, where having 4 distinct seasons is the name of the game.
Yeah, so these temperate zones cover these huge areas in the mid-latitudes of the planet. They're kind of sandwiched right between the super hot tropics and the freezing cold poles. And this is the zone of variety. It's all about those warm summers, cool winters, and, the very distinct seasons of spring and fall. But temperate definitely doesn't mean they're all the same. Not at all. For example, you've got a Mediterranean climate, think Southern California or Italy, which is known for those hot, dry summers and mild, wetter winters. But then you've got a British-type climate, like in Western Europe or the Pacific Northwest, where things are way more moderate. No crazy heat, and the rain is just kind of spread out all year long.
And this climate graph for London, it's a perfect example of that. See that gentle curve on the temperature line? You can clearly see the seasons, but there are no wild extremes. The rain is consistent, but it's never a total downpour. It really is the Goldilocks of climates, right? Not too hot, not too cold, not too wet, and not too dry.
Okay, time for our final stop on the tour. And trust me, this is the big one. We're talking about one connected system. This is where we finally connect all the dots, and I can show you how every single place we've just visited is part of one single global machine. You see this diagram? This right here is the master key.
It literally explains everything we've been talking about. The planet's climate isn't just some random collection of zones. No, it's one giant engine, and it's driven by these massive world pressure belts and the planetary winds that flow between them. This, right here, is our aha moment.
So let's break it down. First, that intense sun at the equator creates a low-pressure zone. Hot, moist air rises and just dumps tons of rain. Remember the tropical engine room? That's what's happening there. Okay, second, that air, which is now dry, cools and sinks back down around 30 degrees north and south. This creates high-pressure zones. And that sinking dry air, that's exactly what creates the world's great deserts. Now it makes sense, right? Third, air always flows from high to low pressure, and that's what forms the planet's major wind systems. And finally, the seasonal shifting of these huge belts and winds is what gives the temperate zones, our middle ground, their distinct seasons. See? It's all one connected system.
So there you have it, this incredibly intricate, predictable, and really beautifully balanced engine that powers the climate of our entire world. It's a system that has been working this way for millennia. Which, of course, leaves us with one last really crucial question to think about. What happens when we start messing with its parts?